ciao Mike.
Good morning, Roberto. Ciao. Ciao.
Good morning and welcome. I'm here to welcome all of you for the second day of work of this workshop. A few words to say that we are very satisfied by the presentations and the topics. I think there is a lot of material for a very exciting final wrap-up. During the first day, we started with the topics related to the eco-sustainable and greening the infrastructure at sea, and then we started the session on the decommissioning of offshore platforms, and this is why we are keeping on this line and concluding this topic to move forward in the second session of this morning. So, welcoming all of you, and we'll start immediately with the second part of the second session, and I give the floor to the chairman, Marco Bora, for the following lecture. Thank you very much.
Thank you, Roberto. Good morning, everybody. So, in the panel of today, we will restart the session 2 on the commissioning. We had an interesting presentation yesterday by Roberto Gimino, Vice President of ENI. And this morning we will start with the presentation of Mark Calverley that will talk about monitoring impacts of the commissioning, what technology can help. Mark, the floor is yours.
Good morning, everybody. Apologies for my lack of not being here yesterday. Oh, okay, there we are. Hello?
Yes.
So this talk is based on a lot of knowledge from some colleagues of mine. I'm the innovation manager at Fugro for the Met Ocean service line, but this really draws on a lot of my environmental colleagues in terms of the deep knowledge they have in this area. This is the sort of thing we're looking at when we talk about decommissioning. These are cutting piles adjacent to a structure that is being decommissioned in the North Sea. So as you can see, they are significant in their own rights. A number of these structures have been around for a very long time, and there's a lot of challenges. I'll talk a little bit about innovation to begin with, and then I'll delve into some of the aspects of what we might do in terms of innovation applied to this particular area. This is a little picture from a UK document called Design in Innovation, and it really talks about the uncertainty in the design and innovation process. And I think one of the challenges we have is the diversity of structures, the diversity of regulation over the years, which leads to a lot of uncertainty, and how we converge and move forward it will be quite interesting. If we look at the typical work breakdown structure for decommissioning, most of these, in terms of the big numbers, the topside removal, whether you go piece large, piece small, etc., there's been a lot of research and development work in those areas to actually determine the best way forward. Monitoring sits aside. It hasn't had the same amount of effort put into it, in my belief. And one of the reasons for this, although oil and gas is very conscious of the environment, it is seen as a cost. And this is a cost against a cost rather than a cost against an upside. So it's quite a challenging situation. The Oil and Gas UK and Decommissioning North Sea actually did quite a good report on the adoption of novel solutions in decommissioning in 2015, and it really did suggest that the idea of creating these narratives in terms of where innovation is required is absolutely key to taking this forward. It also talked about the historic perspective that the oil and gas companies expected service companies to undertake a lot of the innovation work. Well, in the harsh reality of today's market, that becomes more and more challenging for service companies like Fugro, and it really has to be a partnership these days in terms of having a real upside for those service companies to invest in the innovation required, and also working with the universities and research sector. Another challenge, I think, is the regulation side and how we actually get some of these innovations accepted by the regulators. We've had instances where we've tried to take new technologies to the government as the regulator in the UK, and we've been told that we have to look at them on a case-by-case basis, so it would go to the officer looking after a particular case. Now, from our perspective, that's very dangerous from the risk side, because if we take it and it's not accepted and we bid that project using that innovative process which offers us cost savings, we may then get knocked back in applying that innovative process and be hit with a large bill for going back to the old way of doing things. My focus is really on the OSPAR region rather than anywhere else in the world, and OSPAR has a fairly simple guidance in terms of what you do for decommissioning. The focus is really on the verification of the predicted impacts. Typical monitoring is aligned to tidal currents, so you go out in certain distances from the particular asset and you take grab samples and you analyse them for particle size, total organic content, etc. As I said, the change in regulatory environment over the years means that what's going into the water has changed quite dramatically. OSPAR and the oil and gas companies have made a big effort to reduce what's entering the water column, what's been taken up by the sediments. So we have a very different problem to face depending on the age of the asset that you're decommissioning. And this is something that makes a one-size-fits-all in terms of the monitoring solution quite difficult. So it is really working hand in hand with the regulator to get acceptance of the way you approach these things. There's also the field versus wider area monitoring to provide the holistic context, and again, this is quite difficult in terms of how you use those data, I believe. Water column monitoring is meant to be looking at the basically using blue lip mussels for near zone monitoring in cages to look at how they change, and also take up the contaminants, and similarly with wild caught fish. But that really doesn't happen, and I think the challenge there is that certainly with the wild caught fish, you know, they move around quite a lot, so what does it actually tell you in relation to an asset that's fixed in a point in the sea? So OSPAR is only concerned with the actual platform and the cuttings pile. Everything else sits with the local regulator. So we have in the UK pipeline regulations where you don't actually have to remove the pipelines always if you can present an appropriate case not to. And that includes, are you going to see free spans forming along the pipeline which might pose a risk, and are you going to see contamination from when that pipeline actually corrodes away. So a complex picture, and then if we add in all the other activities, you know, we have to look at this not purely as an oil and gas problem, but in the round in terms of the ecosystem. So the eModNet does a very nice job of telling you just how complex this picture is. I think the first thing to start with when considering decommissioning is really having a really good knowledge of what's there. A lot of these assets have been out there for 30, 40 years. what's happened to those assets is not always well documented. It's amazing how sometimes people are asked to decommissioning. The actual cost of that decommissioning is such a big unknown because people don't know what's on the seafloor. So starting with a really good map of what's there is really important. And innovative monitoring components here really are about point cloud technologies, I believe. So 3D, which allows 3D visualization, virtual reality, and subsea tooling. The little thing on the left there is something that we've just put into production. It's a very high accuracy measurement device using blue light, so we can measure to 2 centimetre accuracy. This really helps us to understand exactly where the structures are. If we then have to put ROVs in, etc., to do cutting work, we know whether we can actually fit the ROV and the tooling into the space that it needs to go into. And in Fugro, we do that using gaming technology, so we actually have simulators where we can fly those ROVs in. An interesting thing here is also the world of vision is quite an interesting area. If you look at the medical world, how they use vision technologies is way ahead really of the marine world. So borrowing from adjacent markets is very important, and the way we do that in Fugro is we actually attract vision specialists from the health area into our business to help us create appropriate image capture techniques, but also in terms of the processing. Another area that is not always addressed is the way some of these things are actually contracted, in that environment may be a department sitting over here in a building, I won't say any particular company names, and the decommissioning is sitting somewhere else. And the actual interaction between those teams can be quite poor at times. So the opportunities to actually collect data when you're doing the engineering side are quite high, and actually making sure that the environmental components are in that engineering picture is very important to save cost. In terms of the baseline environmental conditions, many years ago a lot of these platforms weren't really having any baseline environmental surveys, so the information available can be quite poor. This has been quite an obstacle in terms of divestment of some of the older assets, certainly from the majors to the miners who can more effectively extract the last remnants of the gas and oil. But it means that you really have to start at the point of what's there now, and this is kind of tends towards the questions raised about leaving these assets there rather than actually removing them, which has been successfully undertaken in the US and other regions. So can we do that? Well, we really need to build that picture of what's out there now and then build from that. Some innovative areas, maybe in terms of habitat mapping, using backscatter data. It's an area that's been looked at quite a lot, but there's nothing in the commercial world that's delivering this information. It obviously has limitations and is more appropriate for probably hard substrates. The optical platforms, so actually leaving things there to look at various things. Genomics offers some potential in terms of actually understanding or working out what benthic fauna are actually there. The problem that is perceived, certainly from the people I talk to, is that quantifying the number of the number of specimens of each species can be quite difficult using genomics. and also you need a very good database to work from, and perhaps that's missing. I've seen some work where a small number of species are considered, but not the sort of array that might be necessary in terms of decommissioning. The environmental DNA technology is another interesting development that might add value, actually knowing what moves through your water column or in the area of interest, and how you bring that through and then understand those data, I think, will be the challenging aspect. The micro-coring for benthic assessment is something that's often talked about, but you have to have a certain size or volume of the seabed for the analysis, and whether it works with the micro-coring side is unclear. And then the other thing that may offer a lot of potential is underwater mass spectrometry. This is commonly used now in terms of looking for oil and gas, so we're actually putting mass spectrometers onto AUVs and roving around the ocean to really look at the hydrocarbon content of the water column when undertaking exploration. So the flip side of that is, why can't we use them for environmental protection? In terms of the actual decommissioning activities, there's not a lot actually around the risk management during removal, other than the safety case, but in terms of the guidance in the legislation, there is nothing concrete to work against in terms of innovation. So we're in that woolly area in that picture I showed earlier. One thing that could be helpful is real-time data on chemical composition of the water column, so actually understanding what you've disturbed and what you've put back into the water column. The real-time metocean data to try and verify the likely advection paths of those contaminants if they're resuspended too would be helpful. So we've seen quite a lot of landers. Historically they've been quite expensive, so can we create lower cost landers? And I think this is again something where adjacent technologies help us with the decreasing cost of batteries. In Kevin's presentation yesterday he talked about lithium sulfate. I'm looking at aluminium seawater batteries that have 4 times the lithium ion thing, and they're coming to the market now, so that's a very nice thing, because the disposal of lithium is more difficult and less safe than aluminium. With those low-cost persistent landers too, the communication piece is quite important. So can we put autonomous vessels collecting those data from the landers, or do we use buoys and with a hardwire link to the landers? Again, the mass spectrometry could be quite changing in terms of the landscape, and certainly the long endurance AUV that Kevin talked about yesterday is something that would offer a massive difference to the oil and gas industry. I think we operate about 6 Hugans which run in deep water for about 18 hours. So if you can get something that lasts for 14, 15 days, it really is a game changer. And the lab-on-a-chip technologies that are really trying to provide this real-time chemical composition are very important too. The ability to deploy those and have them in a way that they don't need huge reagent bottles, they're not taking huge amounts of power, is very important. Post-decommissioning, I think this is an area that we typically go back perhaps maybe once after decommissioning, depending on the platform and the history of it. So we get a snapshot in time 5 years afterwards. what does that snapshot in time tell us? Well, it tells us that the concentrations at a distance from the platform have moved to a level that is considered safe. Does it tell us a lot about where the things may have gone, the contaminants may have gone? It doesn't really give us anything to really take forward and to learn from. We're just saying, right, okay, at this point the contaminants have gone down, but how do you actually interpret that in terms of creating better policy and better ways of dealing with these issues? So I think the autonomy has a big part to play in this. The little vessel up there on the left you saw in an earlier guise in Kevin's presentation, that's one that we've used for PAM monitoring, which is great because it's a silent vessel, so you can actually hear a lot more in terms of cetaceans. And the other piece is asset integrity sensors, in that even when these assets are in production, they're not always monitored. And if you don't monitor them, you really don't know their fatigue life, etc., and when they might catastrophically fail. So if you plan to leave things out there, you really want to build a picture of how pipelines begin to fail, how they might start leaking any contaminants that may be contained in the pipelines if you haven't managed to clean them adequately. So in summary, I think there's a lot of sensor technology that will allow us to migrate from collection of samples to in-situ analysis. That means we can see things a lot quicker. It means that we can be more agile in the way we actually respond in the field. We're going to see a lot more autonomous platforms, and it's very interesting that the IMO is now working on this issue. I think it's easy in the research world to actually take an AUV or a autonomous surface vessel around the world. In our world, if we want to export, say, an AUV or an ASV to Angola or to wherever we want to take it, because we're a global business, it's pretty challenging in terms of the local regulations. Actually importing an ASV into Angola is now impossible, because you have to satisfy all the SOLAS regulations, a whole raft of different things under IMO that are totally inappropriate to a 3-metre plastic vessel that has nobody on board. So these are the sorts of things that will help, I think, to certainly take the autonomous world forward. And if we've got the regulatory environment secured, then we can really move forward with using these things. The improved power consumption, so reducing the power requirements, and also improving the way we produce energy. Multi-purpose survey activities is another area. Perhaps the biggest thing that will change, I believe, over the coming years is how we use these data. If we can create proper data infrastructure, and there's been a lot of efforts in this area, but there's still a lot of data sitting in private vaults, not being utilised. We can go a long way. And then I think one of the things that will be fascinating will be how machine and deep learning is applied to this world. We already apply it to optical imagery, so can we actually take video of the seabed and identify all the creatures that we see in that picture? Can we inform the connectivity of the ecosystem models? It's very interesting that IBM came out last week saying that they can model wave dynamics, so shallow water wave modelling using machine learning. Can we do the same thing in the ecosystem world? And then also understanding the integrity of the assets. And on top of that, we've got all the data analytics, so can we provide simple ways for people to interact with this and try and pull some information out of these data that are collected. And that's it, thank you. I'd just like to acknowledge my colleagues Julia Root and Peter Campbell, who provided a lot of support for this presentation.
Thank you for this interesting presentation. As a biologist, I have a biological-driven point of view, so I'm happy that you listed in the innovative monitoring components, biological parameters like DNA, environmental DNA, or lab-on-chip technologies that I hope that will be improved in the next years. We have time for one or two questions.
Thank you for this very inspiring talk. I noticed that a lot of this monitoring will bring in a lot of new data in areas that are very poorly known.
Yeah.
So, to your view, how far are we in setting common standards and common protocols in the sampling and the monitoring, in particular for biological data? Because they can bring a lot of new information in areas that are very poorly known. So I would like to hear your personal view on that.
I think it's probably a mixed picture. I think there's some areas that, certainly in our labs we work to common standards, but it is quite mixed. But I think it's how you then on-pass those data with the appropriate metadata and everything. But, certainly we see some efforts to improve that, but it's not perfect, and to exploit the data we really need that. Yes.
Yeah, hi, thanks very much, Mark. That was a very informative overview. Really great, thank you. Just putting two and two together now. So yesterday we got an idea from the presentation that we had towards the end of the day on the size of the decommissioning market over the next couple of decades. So does Fugro have an idea of the size of the future market now, purely in terms of the monitoring technologies that are involved? Now that's a big question. And then I'd like to cheat and add a second question, if I may, and that's about environmental DNA. And if you could just give us a little bit more background there, what it is for non-scientists,
Okay.
and its uses in your particular field.
Well, it's very difficult to quantify the size of the prize for us, if you like, because each one is so different in nature. We're hoping you might tell us the answer, actually. But yeah, I mean, we've done a little bit of work, but we haven't really put a size on it yet. We're still undertaking that work, so if we get to a point where we can actually quantify it, we should be able to share that. Environmental DNA, as I understand it, is bits of DNA floating in the water column that you can sample, and then you can say that, well, that particular species has been in that piece of water. I'm happy to be corrected because it's not my field of expertise.
Thanks, Mark. Impressive list of technologies and potential developments, including striking the use of environmental DNA sequencing rather than in situ mass spectrometry. The point here is the conceptual framework on which you base such a vast array of variables and potential technologies. So, for instance, we have the marine strategy with a framework directive that is addressing the point of addressing alteration of biodiversity, alteration of ecosystem function, say, for instance, food webs alteration, And then the point is also related to sediment or matrix contamination, bioaccumulation, down to noise or liter. So, my question is, how these technologies fit into that? Are they completely independent, so it's purely ecological targeted objective, or these are functional to the marine strategy, which in many cases is something we have to look at, even though maybe it's not addressed to the Commission at this stage?
Yeah, I think what I'd say there is that the regulatory framework has to change to embrace the innovations and the way that we can manage the ecosystem. Because I think at the present time, the regulatory framework, certainly in terms of OSPAR, doesn't give us a clear way to apply these new technologies and really reap the benefits of them.
Okay, thank you. Thank you all. We can welcome now the presentation by Monica Grasso from NOAA.
How do I move the slides? Just with this one. Okay. This one. Oh, okay. Oh, good morning, everybody. I'm here to present the Rigs to Reef program from the U.S. Talking about regulatory framework, I'm going to be focusing really here on how this works in the U.S., who regulates what, and the overall view of the program, and what really triggered the Rigs to Reef program in the U.S. When I say Rigs to Reef, it's really the process of getting a platform, decommissioning, and making it an artificial reef. Full disclosure, this is not my expertise. I'm really representing two different agencies, NOAA and also the Department of Interior. So I'll try to answer any questions you have, but I'll do my best. So the Rigs to Reef program was really triggered by two factors. One is that the recreational fishermen really they associate the quantity of fish near reefs. So there was a pressure from the commercial fishermen to really look into possibilities of having alternative ways or artificial reefs installed in the coast. And also by the Bureau of Safety and Environmental Enforcement. They are the ones that do the leasing of the outer continental shelf land in the U.S., and they're looking for alternatives to dispose the platforms. Things that they're looking at really the design of the platform. So the platform it did have, the big complex one did have a good design for effective water circulation. The material was durable and had enough complex substrate to host marine organisms. And also they support marine species throughout the column of the water. So those are the things that really they're looking at. So they start in 1980s looking for cooperation from other agencies and see how they could make this feasible in the U.S. So, as I said, this was really triggered by pressure from recreational fisheries. And so in the U.S., there was the National Fishing Enhancement Act of 1984 that really formalized the rigs to reef program. The whole idea of that program is really to enhance fisheries, enhance the amount of fish available to the recreational and commercial fishermen. So this act in 1984 really directed the Secretary of Commerce, that is NOAA, and under NOAA we have the National Marine Fisheries Services, to develop an artificial reef plan. So this plan will work as a guidance. It will provide standards for artificial reefs. And the whole idea of this guidance is really to enhance fisheries, reduce risk, make sure we are complying with all regulations, navigational regulations, etc. And then it also directed the Secretary of Army to really looking into the regulatory framework and do all the permits, all necessary permits. And this was very interesting. The way it was done, they delegate this permit to the Army Corps of Engineers in the U.S., and this is an agency that is not really centralized. It's very dispersed in the states. So they delegate to the states, to the districts, the permitting process. So as I think Mark said, the Rigs to Reef program is really, it's evaluated case by case basis. They look at during the permitting process, they're going to look at the engineering standards, environmental standards, and compliance with the national reef plan. The good news for the owners of the platform is that they have, once they get into the program, they have some flexibility with the regulatory framework. So they have, usually when the lease ends, they need to remove the platform within a year. Now, if they apply to be on the Rigs to Reef program, they have flexibility that is negotiated with the state. Use of explosives was used in the beginning of the program. Now it's highly discouraged due to damages to the marine life. And they also don't recommend to make artificial reefs from rigs that are being removed by the storm. It has to be something planned. It's not just a rig that it's going to stay there. So again, the way it works, it's really in the U.S. now. It's supported. This program is supported and encouraged, but they need to follow within. They need to be within the state reef program, and they need to comply with the National Artificial Reef Plan. The way it's done is very interesting because the state agency will work with the platform operator, and once they enter an agreement and it's part of the state plan, the state actually, once the platform is decommissioned and becomes a reef, the state assumes the liability for that platform. The state is in charge of monitoring the platform and doing any other reporting related to that platform. So once it became an artificial reef, it's the state that is responsible for it. When you apply for this program, you also need to comply with the U.S. Coast Guard with navigation requirements, and also with all the engineering and environmental requirements from the Bureau of Safety and Environmental Enforcement. So on the NOAA side, and later I'll show you how complex this program really is. From the NOAA side, because we are in charge of monitoring fisheries and marine protected areas and sanctuaries in the U.S., we are responsible for the plan. We are responsible for putting together the guidelines that the states and the owners will have to follow. The guidelines, when they were published, it was explicit that those guidelines are not set in stone. Everybody recognized that this is a new program, and the guidelines need to be dynamic, and they are open to change. So in 2007, we had an amendment to the Artificial Reef Plan, and this is an ongoing work. They're still working, looking and monitoring results and see if there are standards that need to change. There is one of our national marine sanctuaries that accepted one platform now, and it's under monitoring, but it's really the national marine sanctuaries. It's open really. The goal is to bring people to visit the sanctuaries and admire the marine life, and they're looking into the platform and see, is this really making results? So we have one so far in the national marine sanctuaries. So just to illustrate how complex this is, we have just basically 5 agencies. The 3 top agencies are the ones that are more heavily involved. So we have the Bureau of Safety and Environmental Enforcement. That is the one that is responsible for the land, the leasing the land that the platforms are using. The NOAA, that is providing guidance for the whole program. And the U.S. Army Corps of Engineers, that are coordinating the reef permitting with the states. The U.S. Fish and Wildlife is another agency that does help with grants and monitoring of those areas. Department of Navy has a special permit, and they can actually sink any structure or vessel according to their own program. So they're independent of this whole rigs to reef. And we have the Coast Guard that is responsible for navigational requirements and rules, and the Environmental Protection Agency that looks at the quality of the water. So it has to comply with the Clean Water Act. And how it works, so here you can see that, first of all, the state needs to develop their own artificial reef plan, following the guidelines provided by NOAA, by the plan. And so the state's rigs to reef coordinator, they need to identify the area and make sure this is an area suitable for the program. And then they work with the rig operator to develop a proposal. And this proposal will go to the U.S. Army Corps of Engineers, and they're going to check and make sure it's okay with all regulations. And then the final approval is given by the Bureau of Safety and Environmental Enforcement that will work with the rig operator on the lease terms for the platform. So, so this is the regulatory framework. I know Mark said that it needs, we need to look into that regulatory framework. But understanding the framework, you can see who are the key organizations, the key partners that you need to work with if you want to make any changes, or where are the opportunities, and who are the really key people for you to contact. Now going just an overview of the Gulf of Mexico, where we have most of our platforms. So the states from the Gulf of Mexico, they all have their own reefs plan, artificial reef plan. And besides those states, we also have California with an artificial reef plan. This, if you look at the image on the bottom, this is from a work from 2017, just showing the red, all the artificial reefs in the Gulf of Mexico. And this is not just platforms. It includes many other types of artificial reefs. Like they used to use tires, they're not using tires anymore. Any other vessels, a lot of vessels were sunk in the Gulf of Mexico, and a lot of pre-made artificial reefs are there as well. And then in blue, you have all the oil rigs platform, the locations in the Gulf of Mexico. So there's a lot going on there. And this is really just an overview of what we have up to. I think this data is from 2016. If you see the pictures, those are the typical platforms in the Gulf of Mexico. Most of them are up to 100 feet in depth, and they are not, those are not the ones really most used and feasible to become an artificial reefs or be in the Rigs to Reef program. This program is really looking into big and complex designs of platform. You don't want any platform that won't really provide a good substrate for the marine life, or will represent an issue on circulation of water and navigation as well. So most of the ones that are going to be really feasible for the programs are the ones that are more than 200 feet in depth. And here's just an illustration of the percentage between 1987 and 2016. The percentage that did become an artificial reef, and you see that 200 feet plus is the vast majority. Here's just an example in the Louisiana, one big island, the artificial island, Eugene, has 19 artificial reefs structure. It's a very complex and big artificial reef in Louisiana. And my last slide is really just looking at this program in the U.S. and what really triggered the program. That was a program really was focusing enhancing the fisheries resources. So one would ask if is it really working? The states have been monitoring. It's from my quick research on this topic, it's really hard to monitor and figure out, because it is, if you compare to the whole ocean, it is a small area. I saw this study. It's a recent study from March this year on the red snapper. The red snapper is really recreational fisheries and commercial fisheries, very important in the Gulf of Mexico. And they were trying to really measure and see, does it help with the stock? Does it really increase the production? And as you see, I just want to point this out, that the conclusion of the study is that really the impact is really on production is really small, because, and hard to measure, because it's really a small area. And they also look into the potential for increasing the biomass and the spawning, and it's really small, because majority of the species in the platform, they are young and at small size, so it didn't really increase that much. But this is an ongoing monitoring, so I think there's a lot to learn still from this rig-to-rig program. I think that's all I have.
Thank you, Monica. Very impressive the picture with the Gulf of Mexico, all the red and blue dots almost covering all the coastline. Questions?
Thank you very much. And of course, in Europe, we look with special interest to the experiences you had in the United States, because after with the bird spot or whatever, the cases in the North Sea and the offshore decisions, the idea of collapsed. We have a very, very tight and strong limitation in the Mediterranean Sea because of the Western Convention, the London Convention, whatever, that see this kind of decommissioning as a real dumping and opportunity for big companies to escape from their obligations. It is very, very nice to have, and I think we share the approach you propose that there's a tailored, case by case, specific conditions. That means that identifying each platform in the context of environmental. But after all, possibly this discussion, as I perceive it in Italy and in Europe, could be, well, it is evident that there is more life there. It is less evident how much this biodiversity alive changes the biodiversity and function of the system of local scale. Mm-hmm. But even more, the point is, these infrastructures are metal-based infrastructures, so they release in time heavy metals. And they release the metals that will be pumped and used by filter feeders, so they will enter in the food webs. So how this contamination has tested, expanded, is a real concern on the basis of long-term results, because some cases are dating back to 20 years, maybe the first degree. There is a real evidence of that, of a metal contamination, and even more importantly, because we have to use a conservative approach. A conservative approach means be sure in any case that that was your case, but here could be different. Are there technologies to minimize or buffer the potential impact and release of heavy metals? Is there any idea or project?
Not that I know of, and again, I'm not the best person to answer that, and I can get back to you. But As far as I know, there is no pre-treatment of the platform. It's really based on the metal and engineering standards, and if they follow the standards, they'll be potentially they can potentially become an artificial reef. But I'm sure there are a lot of monitoring in the chemical side. Again, what is difficult to measure just in situ because of many issues with ocean current and other things. But it does, just being a person that was not familiar with this, the whole process, since last week, it did alarm me, the amount of platforms there are in the Gulf of Mexico. And the future of this rig-to-reef program is, are we going to keep having that many artificial reefs? Up to what point? What point are we considering as a saturated environment for this type of decommissioning? So I think it's still open. I do think there's a lot of progress in the technology, a lot of monitoring. The states are really monitoring very close those platforms, and it's just, I think it takes a while for us to really learn.
There is another problem in the Gulf of Mexico, which is the dead zones. There is the largest dead zone of the planet, the size of New Jersey in New Mexico. And this is due to the influx of nutrients that come from the Mississippi. So there are lots of nutrients, noxious algal blooms, the nutrients become algae, then there is anoxia, and everything dies. Maybe diverging those nutrients, but the solution is not to use all these fertilizers, of course, but using these nutrients to make other things grow, maybe on artificial reefs, might diverge these fluxes in some way. The platforms might even be a solution instead of a problem if inserted into an holistic vision. Because the problem in the Gulf of Mexico is the dead zones. This is problem number one. The platforms are another problem that might become a solution, maybe, at least in part.
Mm-hmm. And I think each state is really looking, they have their own plan, so they can really tackle the problem individually, look at this issue and find the right place to put it. I'm not familiar with a specific plan from each state, but I'm pretty sure they take this into consideration.
Another question?
Yes, it's a question for clarification. This artificial reef program, if a reef wants to be a member of that program, has it to be decided during the design phase, or can you join it during the lifetime of the reef?
I think both cases. So when the owner applies for a leasing with the Bureau of Safety and Environment Enforcement, they need to have a plan on how they're going to decommission. So they can either contact the state and join the program right in the beginning. But also, if they were there and they want to get into the program, they can contact the state and see if there's a possibility of that. And then they need to amend their lease with the BSE. So there's two opportunities for that.
Thank you.
Move next, the last speaker of the session. That is Mike Elliott. Unfortunately, it was not able to reach Naples, but he will be connected by Skype and his presentation by Skype. Mike, are you there?
Good morning, everybody. I'm just I'll just share my screen with you.
Thank you.
Okay, good morning everybody. I'm really sorry I can't be there. It looks a great set of presentations, and even the three that I've just heard from Roberto, Mark and Monica were really good. And they set the scene for what I wanted to discuss with you. And it's always good to also talking to my friend Roberto Navarro. We just finished a large project together, so it's good seeing Roberto as well. What I want to do is pick up on some of the threads that have just been mentioned, but on the holistic system, but also on how we harmonise the decommissioning with some of these things. Now let's work on the basis that everything we do is risk assessment and risk management. And there are good systems now, and very well accepted systems, even ISO systems, for risk management and risk assessments. One we use is using a thing called bow tie assessment. But in essence, this is what we're doing in trying to decommission and find out the effects of decommissioning on the overall structure of the system. I should say I'll be sending my presentation to Anita and Margarita, so if anyone wants it, they can get it then. And I'm very happy for people to use the slides I use anyway, it's no problem. No. I think this is what you've been talking about, so I shan't spend much time over it, but this shows both sorts of the problem. On the right-hand side there, it shows all the oil and gas installations in the area that we're working on, the North Sea, and then the two smaller maps show the marine protected areas, the nature conservation areas. And it's really the way these two come together. But what I want to show is that we can't just look at nature conservation, we have to look at many other things as well. So I don't need to spend any time on this because you're all well aware of what we're trying to decommission, and that former slide showed there's something like 8,000 structures inside the North Sea alone, but that's all structures, that's the mattresses, pipelines, rigs and so on there. But it's always good to understand the nature of the problem. If you understand the behaviour of the system and the behaviour of the activity, and every one of these, the mattresses that you see there, the pipelines and so on, the rigs, they all have a behaviour. So what we're needing to look at, and we're involved in a large UK problem with the project with this, and I was at a workshop, I was leading a workshop last week on this, and it's really looking at the structures to be decommissioned, where they relate to marine protected areas, the options available and so on, and especially the potential impacts. Now, the innovation here is not just innovation in techniques, it's innovation in the way of thinking. And what we've started to do now is see the way the scientists and the industry are starting to converge in their way of thinking about these, and then bring the regulators on board with them. But of course, none of this is new. I sort of went back to something I wrote, as you see, sort of 20 years ago. Where some of you remember sorry about this. Some of you remember the Brent Spa trying to remove this oil storage void, and it was going to be dumped off the northwest European shelf. In the end, it wasn't. It was taken. But we had the background for things like this. We've now not only been looking at oil and gas, but we've been looking at offshore wind. And although the offshore wind farms are only just going in at the moment, we're still thinking about decommissioning them. And as you see from that bottom paper there, the Renewables to Reach programme, we were trying to take lessons from the projects that Monica's just been talking about and apply them to wind farms. And given that some of the largest offshore wind farms that are going in now, the one in the middle of the North Sea could be about 1,000 turbines, then this is going to be an increasing problem as well. So, I'm not sure why that keeps happening, but we'll see. We need a background, an overall framework for this. And this is the framework we've been using for a while now. Some of you will be very familiar with the DIPSIA framework, the driver's pressure state impact and response framework. Well, we've modified this over the years, and Roberto D'Anvaro was involved in one of the projects, DEVOTES, where we were involving this. The idea we have basic drivers which require activities that lead to pressures which are a mechanism of change on the natural system, and they lead to impacts on our system, on welfare, for which we need responses. And this is what we've been calling DAPSWORM. I started off as a benthic biologist, seabed biologist, and so DAPSWORM is apparent. But you'll see the paper that's just come out there if you need more information. So let's apply that framework to the decommissioning. The drivers, in this case, we've got legal drivers, but also we've got societal drivers for what we want. The activities that you've just heard, and Roberto Cimino was talking about this yesterday, all the different activities that we've got there. The pressures that come from that, the mechanisms of change, and you see there that we've got a whole load of these. We've got very good matrices now for pressure impact relationships, and of course they lead to state changes on the biological system, state changes on the natural system. And here we're not only looking at a loss of habitats or loss of species, but when we decommission, we're talking about a gain of them. And we also may have talked about a gain in these, in actually putting structures in there. Then we move on to the impact on human welfare. And this is where some of you will be familiar with the idea of having ecosystem services provided by the environment. These then lead to what we call societal goods and benefits. If the ecosystem can produce its services, then we can go out and do something and get the societal goods and benefits. And so what we're now looking at is trying to estimate what is the removal of these, the removal of rigs and any other structures, and how this has an impact on these ecosystem services and societal goods and benefits. And then, of course, there's the responses that we use. And I want to talk a bit more about these responses. What do we do to counteract either the problems in this or enhance the benefits? And some of you, I know Roberto has seen this diagram a few times. A while ago, we did an analysis of all the European legislation and some national legislation required to manage the marine environment. This was published in Marine Pollution Bulletin in 2014. Move that down there. In 2014. I can't go through all of those, but the ones I want to focus on are a couple of these which aim to get good environmental quality and also to allow us to spatially plan the system. And this, in essence, is our stylized marine area. Not only have we got all these activities, and you see down there there's an offshore wind farm and the oil and gas there, but it's a whole load of other things happening. And this shows the legislation framework of where in Europe all of these bits of legislation go to. Now, when we've looked at other countries like the US and Australia, it's exactly the same sort of framework. It's just as complicated, and Monica mentioned this. So when we're trying to convince policymakers and indeed industry how to act, we focus on this, the one big idea in marine management. How do we maintain and protect ecological structure and functioning, which in Europe is the Marine Strategy Framework Directive, while at the same time allowing the system to produce ecosystem services from which we derive societal benefits, which is the newer Marine Spatial Planning Directive. And just very quickly to go over those, each activity in the sea has got a footprint shown by those dashed lines. And what we've just been looking at is how to quantify those footprints and merge them within a large area like this. This paper has just been submitted, so hopefully it will come out soon. So we've got these two directives. The MSFD, the Marine Strategy Framework Directive, which is based on descriptors, and then the Maritime Spatial Planning Directive. Well, let's try and work out why there is a problem in trying to harmonise these. And one of the problems is that the activities that are out there are not where we want them to be, but usually where they can be. And this means that the oil and gas activities in wind farms are likely to be trying to occur in the same area as nature conservation areas. So we have to try and accommodate these and come into them. You can imagine the marine area as having a sort of a good status, which is this top line up here, a good status, which, or rather a pristine status. And what we do is when we keep adding activities, we use up some of that pristine status. When we put in mitigation or removal, we actually might regain a bit of the status, and that's what this line is here. So we've got an underlying conceptual model of what we do. So let's just very quickly go through the these 11 descriptors. And Roberto Danararo asked in the previous talk about the way the decommissioning affects these different, the MSFD and its descriptors. And so I'll give you a chance to read these later. But actually, as you can see from this, what we've done is gone through each of the descriptors and then seen how both the presence of the structures, but also the removal of them or leaving them in place is important for the MSFD, for the European directive. And so you'll get a chance to read this later. And then the last one, and I think this is one that Roberto also touched on, the last one there about energy and noise. You see, some of these, we don't quite regard these as being that important these days. For example, some of the contamination in the environment and contamination in seafood are not regarded as too important, mostly because if you can trap the pollutants, then they don't get disturbed, then it's okay. And just going back to Roberto's question just now about the release of pollutants from reefs, what we've found, we've been doing some work on wrecks and sunken ships, and it shows that once these structures get covered by the biota, by the fouling organisms, then it reduces the release of these contaminants. So there are these things to be taken into account. Now let's just very quickly talk about the solutions to this. And again, some of you, especially Roberto, has heard me talk before about the way we've come up with a set of what are called tenets, which are like underlying rules for how to get management measures and responses. What I quickly want to do is talk about all of those tenets in relation to decommissioning. As you see, we've published all this before, so you can read it at your leisure. If you can't get to sleep at night, then just try reading some of this. But you see those 10 things there. Let's just quickly go through there. One of the discussions we're having at the moment is the way the seabed, with the structure in place, has reached an equilibrium that is different from what it had before. When we want to remove the structure, are we going to try and regain the equilibrium it had originally before the structure, or will there be a third equilibrium? And what is the disturbance of this? Now, I think someone mentioned just now that the baseline is very poor for these. I think Mark mentioned the baseline is very poor. We don't know in many cases what was there before the pipelines or reef were built. So we're now thinking about, well, our baseline reference condition probably has to be with the structure in place. This is what we were discussing at the workshop in Glasgow last week. But when you look at this, there are both ecological benefits for leaving things in place, but also ecological impacts. What we now come to the conclusion is, and this is what Monica was talking about, that in certain areas it's actually better to leave these in place. Not least when we want to look at the whole system. And then we come to the technologies. Can the structures be replaced? Should they be left in place? And so on. Monica said about use of explosives not being used, but actually there are new explosive techniques of removing rigs where the explosives are inside the rig rather than outside the rig, and it's actually a much easier way of removing things. When it comes to the economics, we're talking, and I think Roberto Cimino talked about this yesterday, the whole life cycle system. And what we're now thinking about is not only the benefits of recycling materials, but what is the cost of the energy, in what energy do you have to put in, and what's that contribution to greenhouse gases by putting that energy in. So the economics has to go from not just the economics at the site or the routes getting there, but we're now talking about much wider economics. So this comes back to the use of platforms and making economic benefits of leaving things in place, as well as the economic benefits of removing them. Of course, job creation is a large economic benefit. But what does society want in all this? Now, is society happy to see them in place, which in the Gulf of Mexico they perhaps are, or does society want to have them removed, or indeed does society not care what happens to them? However, given that society might end up picking up the bill, and the cost for the North Sea for decommissioning is anywhere between about 40 and 90 billion euros, and a lot of that would be picked up by the taxpayers, then of course society will get concerned. I can't go into much into the legal side of this, although we do a lot of work on this. But there are mechanisms now, and what we're trying to do is start saying some of these should be challenged. So, for example, OSPAR 98.3 could be challenged as far as leaving rigs in places. At the moment, I think as Mark said earlier, OSPAR deals with the rigs and the above surface structures, and then the pipelines and cables and mattresses are dealt with locally. And it's now become more common that those are left in place, because removing them would probably do more damage to the environment than leaving them, especially for any nature conservation areas nearby. And then the last ones of these on the administration, the politics, the ethics, the culture, and the communication in this. And that. The ethics is an interesting one, because we're now looking at the ethics of doing something in the environment now where we don't end up paying for that, but we leave the debt for our children and grandchildren. And I'm sure my grandchildren won't thank me if I leave them with a very large bill or trash in the sea for later on. So we're now trying to bring these things together. And of course, as we've seen, the political expedience is important. The politics is now probably favouring industry sort of on all sides of the Atlantic, and so trying to say, okay, well, the politicians might think more about what this does for industry more than anything else. So let's just bring this together. The questions that we're looking at now and trying to quantify are things like, the loss and gain of these habitats and surfaces by either removing things or leaving them in place. What are the overall benefits? What are the benefits and losses in ecosystem services and societal goods and benefits? Does the reef approach work if it produces fishes and benefits from those fishes, as Monica described? The value of removing the structures, can we remove them with or without damage? And even the environmentalists are now starting to say, well, actually, the damage caused by removal may be a lot more than the damage by leaving them in place. And then the thing I mentioned just now about the whole system, the energy and economic budgets. Where do we stop? Where do we make the limits of the footprint? Is it the fact that in order to remove some of these structures, we have to build boats, and some of those special vessels are being built in Korea and China, and so does the footprint extend that far? So the whole environmental footprint is important. The protection to other users and users. Now, we've been doing work with the fishermen on how they respond to removing structures. And of course, on the one hand, the structures have provided a no-take zone for fishing. So you think, well, if we remove them, then the fishermen can open up that area. But actually, we're also seeing that the fishermen are targeting their trawling alongside pipelines because they know they get more fish there. Relevant baseline, I touched on this earlier, and if you're trying to monitor anything, and you need the monitoring to inform management, then you're monitoring against something. You need to know what was the level that you were monitoring against. And we, like Fugo, have got a large benthic lab that does a lot of monitoring to very high quality assurance levels. But in doing all that monitoring, you have to know what is the change that you're likely to pick up there. For example, in some of the monitoring that's recommended, the industry has been told to take a few replicates at each station, and we've done the analyses to show that in order to detect a change, you might need something like 75 samples, not 4. And then that second to last point there, the harmonised implementation of the various directives, trying to get good ecological status for the Water Framework Directive. This relates in Europe to within 1 mile from the coast and slightly further to the chemistry. Good environmental status for the Marine Directive and favourable conservation for the Habitats Directive. And some of you who keep up with European legislation will have seen the latest European communication which links the Marine Strategy Framework Directive and the Habitats Directive. And dare I say it, for those of us who are living in a stupid political system that seems to be pressing ahead with Brexit, unless we can manage to stop it, then we will still keep implementing these directives. But I'm afraid I'm doing my best, as Roberto knows, to try and stop this stupidity. But all our countries seem to have stupidity at the moment. And then the final point there about what are the bottlenecks, showstoppers and train wrecks. If you deal with industry, they discuss their problems and their impediments to action in these terms. A bottleneck is fairly simple to move, showstopper takes a bit more, and a train wreck means you're not doing anything. And so industry is trying to look at what are the impediments to achieving what they want to do, which is a safe and environmentally sound way of decommissioning these. Last slide for the end one. Just to mention one of the projects we're working on at the moment, and you see we're leading this, but it's got a set of other partners there, is in the process of trying to create a decision support framework for oil and gas decommissioning. It's trying to put it into a system of how do the regulators and how do industry make decisions, and are they defendable both scientifically and also legally? Are they defendable decisions? And as you see there, we not only have the regulators on board, like our Nature Conservation Committee, English Nature, Natural England and JNCC, but also the government department regulating this, and Shell. So I realised that was a very quick look through at the discussions at the moment, and as I say, I'll send these to Anita and Margarita so you can read them later. And say if you need any of the information, then get back in touch with me. I say we're all working on several of these projects at the moment, both at a European scale and in Australia. But I say I hope that's been useful, and I hope it's added to the meeting there. And again, my apologies for not being able to join you. Okay, thanks a lot.
Thank you. Thank you, Mike, for your very rich presentation. Questions?
Hi, please, Roberto. I want to just to break the ice. Thanks a lot. Of course, you know how much I agree with your position. The reason why I want, I think your presence here is very important. Is that I know that you led some discussions in UK recently. There's a lot of ongoing work. There are a lot of projects inside, whatever. And there is a lot of thinking. So I was anticipating that we do need to think more about how to proceed and to instruct in a intelligent way to fight against stupidity in these approaches. So I fully agree with you. My question is referring to one very short comment you made and the list of things to do. Most of them are clearly still open, but one was very, very, my opinion, crucially important. You mentioned, in some cases at least, decommissioning could have an impact much higher than leaving the system in place. My question for you is there evidence about that? Are there data, I mean, sound, solid scientific data, not legal basic data, but environmental, ecological data supporting this? And to your opinion, on the line of the previous also, presentation from the case of the United States, is sound an approach case by case? So it might be the case in which some platforms have to be removed entirely, while others should be better left on place, at least with partial decommissioning, to reduce the overall impact. Thanks, Mark.
I fully agree, Roberto. Monica talked about these depth limits for whether things will be left in place. And I think in the North Sea, I think we're using 55 meters is the critical amount above the platform. If you're going to leave something in place, then there has to be 55 meters above it. So what this means is the whole of the southern North Sea, which is mostly gas platforms, that it's unlikely anything will be left in place there. Even though a reef there would actually be quite good. And I liked Marco's comment about using the reefs to increase the biomass and soak up nutrients. But of course, in order to do that, you have to have the reef in the photic zones. So certainly in the North Sea, it's likely that it will only be those areas, 100 meters and deeper, sort of further north, where we would have those reefs. As for the effects, the wider effects, we did one project where we're working with an oil company on the environmental effects of cleaning the jackets in situ and moving the jackets on shore to clean them. And what they were asking us to look at was the effects of health on the divers compared to the health of people living in the area where the rigs would be decommissioned if you bring them on land. The point I was trying to make, Roberto, is what we started doing, and I was doing this with a good friend Lawrence Mee, who sadly died too young. And this is starting to look at saying, well, what is the energy budget? And it's not just the energy budget of cutting up a reef and lifting it onto a barge, but the energy budget of getting the boats there, the energy budget of cutting it up on shore. And we saw this with the Brent Spa. So it's trying to find ways of saying what is the footprint and the footprint, as I mentioned, could extend as far as China if they are making the equipment that you need in order to do this. Now, of course, some of that is countered by the fact of people saying, oh, well, it's good job creation as well. So are we doing things for the environment, or are we doing them just for job creation as well? But I think your question is right in that we need to start trying to quantify these so that we can present the regulators and the industry with very good data.
Thank you.
Hello, Mike. It's another here. Thank you for taking a stand and a clear position on this issue. I appreciate it. And you mentioned that you conducted a study on some legislation or practices at the European level as well as national level sometimes. I was wondering if you could indicate possibly some more virtuous practices or regulations in specific countries which could lead the way, perhaps, or some comments around this area.
I would like to be able to answer that very easily, but of that what we call the legislation horrendogram, the title is the ultimate horrendogram. Of that legislation horrendogram, there's quite a few elements there that the industry has to be aware of. And I think this is the problem, that the industries are very good at their, let's call them their technical regulations. No, the regulations needed for building their concrete structures. But they need the help of people like ourselves and some of the others to try and look at the way the legislation fits together. I can't. It'd be nice to actually just go through that horrendogram and then just help you with where there are good practices. We'll probably have to talk about this offline, but one of the points I would make is that horrendogram looks quite complicated. But actually, when we've looked at other countries as well, their legislation, the US and Australia and Canada and so on, and South Africa, they all have similar complexity. And also, Monica touched on this, they have a complexity in the number of organisations that are involved. Now, in England, we've tried to simplify this by having one marine management organisation that hopefully will be a one-stop shop for industry. But even that doesn't help with decommissioning, because the marine management organisation will be involved in maritime spatial planning, but then we have a department for business and skills that is the licenser for decommissioning. So I think there is some good practice around, but also I think we also need a system of learning from each other.
Thank you. So if there's any other questions, we can close the session. We are almost running on time, considering that we had to speak more than the agenda this morning. I want to thank you, Monica, Roberto, Mark, and Mike, for the contribution in this session. And we can move to our coffee break. And Mike, you can have your tea if you want.
That's very kind. Okay.
Thanks.
Thank you.
Bye.
Bye.